welcome everyone. Thank you for coming. Of course, we begin the day by acknowledging the Gadigal people of the Eora Nation, traditional owners of the land on which we meet, and we pay our respects to the elders past, present and emerging. So thank you for joining this seminar this afternoon, which is jointly convened by the New South Wales Smart Sensing Network and the Academy of Technology and Engineering. And we have representatives, of course, from both in the audience as well as from the industries that are involved in this important topic. I don't need to tell you, you'll hear a lot more about the reason why this is an important topic throughout the afternoon, except to say that we need to do better on plastics recycling. In 2017-18, Australia processed less than 50% of its plastic, recycled less than 50% of its plastic, and this is going to change quite rapidly in the next few years on the basis of policies not only in Australia but also overseas. For example, the ban on exports of plastics from Australia to be processed elsewhere. The Smart Sensing Network is celebrating today the success of the 1.5 million Cooperative Research Centre project, which was spearheaded by the network and has examined in conjunction with its partners, from whom you will hear today, the increased recycling of plastics by sensing and treating label contamination. And secondly, we'll discuss the topic and the results from the CICP project in the context of the Academy of Technology and Engineering's report, which was launched in November last year and made several recommendations that are specific to the design, in particular of plastic products and plastics recycling. We've got the right mix in the audience, people from industry, academia, government, to address this question. And it represents the aim of the Smart Sensing Network to develop very strong, collaborative, innovative and effective networks that will deliver social and economic benefits, in our case, to New South Wales. But of course, we've got lofty ambitions to extend those across Australia and across the world. I would like to introduce as our representative from government today, and it's my great pleasure to introduce her, the Honourable Gabriel Upton MP, Parliamentary Secretary to the Premier, and member for Vaucluse. Gabriel has been very active in New South Wales in the last, in the last 2 years, leading the accelerating R&D initiative in New South Wales, and she will tell us about that, which also is an ambitious plan to increase R&D and innovation activity across New South Wales. So welcome, Gabriel. Thank you for coming.
Good afternoon, everybody. I think we're virtual as well, aren't we? So hello, virtual audience, and thank you to Susan for that kind introduction. Also to Nick Haskins, who I know has had a lot to do with organising today, and good to see Catherine Fagg, of course, Chair of ATSE. There may be others that I'm not acknowledging, and my apologies for that, but it was so wonderful to get this invitation from Susan, who I've had dealings with in the last number of years, in particular the last year when our accelerating R&D initiative in New South Wales has really kind of hit its straps, as we say. Before I get to what the accelerating R&D action plan is for New South Wales, I wanted to just talk a little bit about the environment and my experience, and particularly the technology that is the focus of the forum today. And I do this with knowledge, I suppose, of some of the issues around the environment. I served as Environment Minister until 2019 in the state. So I don't pretend to be an expert, but I do know some of the policy issues associated with the environment, particular recycling. So if you'll give me a little moment, I wanted to provide some kind of insights that I took from that experience of 2 years in stewarding that portfolio in New South Wales. So, you know, one of the things I learnt when I was at school was that the First Law of Thermodynamics, which should be well known to those of you who are academics in the audience. But, basically that principle that matter can't be created or destroyed. It simply moves from one form to another. And I think as a modern developed economy, and I speak with my hat on as a New South Wales representative of the government, we've really ignored that over time, and it has been to our peril. It's really an inconvenient truth that, whether it's empty glass bottles or it's cans or plastic bags or whatever, food scraps, coffee cups, you name it, or fast fashion, it just doesn't disappear when we finish using it. It doesn't get destroyed or created. It simply moves to another form. And of course, we've had an approach which traditionally has been, taken to landfill. That's where most of our waste still in this state ends up. And then we kind of forget about it once we put it in our bin at our curbside. And I must say tonight or tomorrow morning I had my curbside collection. So, we just kind of think, well, it's done. Well, I've had some insights which, of course, lead me to understand that is indeed not what happens. And I think from the government's perspective, we have now come to a stronger focus and understanding that, to have that approach of it's all done at the curbside for people and for industry and other ways I'll come on to discuss in a moment. That's very irresponsible, of course, and that we need to own our waste because it simply transmit into different forms of matter that we also are responsible for. I was introduced those years ago to that concept of a circular economy. And of course, the premises there, as you know, are to reduce waste. First off, you reduce it. Then if you can't, you try and reuse, or you reuse what you can't reduce. And then, of course, you recycle. And it's that kind of virtuous cycle that underscores the work that's been done here. It's not easy, and it does challenge local councils, local government and federal governments and all members of our community. But putting waste into landfill, as I said, really must be the last resort. I know that plastics in particular is a really wicked problem that we have in the state and nation internationally. Plastics is such a ubiquitous commodity in our lives. It's become very cheap. It frames a lot of things we do every day, and we almost don't think about it. It is something that frames the way we get about doing things. I was actually there in Canberra meeting with my counterparts in states and territories led by the National Minister at that time when we signed up those 2025 targets with the Australian Packaging Covenant. And I think we have some of the leadership of the Covenant here with us today, and they are ambitious. So I remember being prepared for that meeting before we went to Canberra and discussing with my counterparts, being ambitious but reasonable. You need to set a target that you can achieve. You need to have a stretch target, but you need to have ways of getting to that target so you just don't keep rolling on and missing targets, which is disenchanting for everybody. So, of course, they are ambitious. They are 100% reusable, recyclable or compostable packaging by 2025 and 70% of plastic packaging being recycled or composted. Then I was involved in Return and Earn, which was our state's container deposit scheme. So that was introduced, I don't know if you remember, it's now more ubiquitous than it was when it first introduced, but it was introduced in late 2017. And again, it was ambitious because it was logistically challenging. It was a purpose-built mechanism where people could deposit eligible containers, not every container, some of them plastic, of course, into the deposit centres that were placed around the state. It's come a long way since I introduced it, and as you can imagine, changing patterns of behaviour and engaging with industry, government policy and a complex new system with incentives in different places. The simplicity almost belying the complexity of the industry impacts and the logistical challenge of rolling it out. Was challenging, as I said at the time. But now when I looked at the figures last night when I was reflecting on what you were doing here today in my speech, there are 11 billion eligible containers that have been returned through that scheme. Now, not every container or drink container is eligible through that scheme, but that's extraordinary. And I've been to, not recently, but 2 years ago, of course, I was visiting the sites where this collection was aggregated, and it was astonishing. There were mountains of plastic and glass that were being stored in some of these facilities ready to be recycled. So I'm predisposed, as you can probably hear, to love what you're doing. I really do know a little bit about it, enough to be dangerous. But, you know, the purpose of what is being done and focused on here, and I congratulate the network on it, is increasing the recycling of Hdpe milk bottles by sensing and treating label contamination. And what I love about this, which is at the heart of what networks do, it brings together cross-disciplinary research focuses. So if you look at what is embodied in this, we've got a couple of universities that have come together, USyd, UTS and the University of New South Wales, and then in partnership with industry, which is fantastic to solve a practical issue which is going to require or enable an uptake of recycling plastic milk bottles effectively. And of course, the dairy industry involved, as we know, Pegris and label makers. So congratulations. I really related to the work that you're doing, and I could see the power of it and the simplicity of it. It is discrete, it is focused, but it's a part of the broader recycling initiative which governments must support industry and science address for the benefit of our community into the generations that will come after us. So now turning for a little while to the Turning Ideas into Jobs initiative, it's our Accelerating R&D action plan, and the Premier launched it this January. It's about doing more of what I understood, being a member of the government for the last 10 years, I had seen done, but I was resolved that we could do more of the turning of ideas into jobs, the translational commercialisation of research. At the same time, you know, solving industry's problems, unlocking jobs, which is what governments, particularly in this COVID pandemic, are very focused on building and maintaining, and then creating the future, new industries, new markets that would come from those industries. And I think if you look at it from a kind of policy perspective, why did I go into politics? Why am I part of a government? What does a government strive to? Yes, you have to do things every day to enable a policy agenda which frames why you're there and why you're elected. But you can sum it up at kind of the big picture. It's about creating a better life experience for people, a better environment in which we live day to day. And that's the responsibility of government, to think the big picture beyond the day to day. So the momentum from the Accelerated R&D action plan came from a discussion I had with the Premier about 2 years ago, Susan, and literally a conversation in her office where I said, I've observed that we have so many critically important ingredients that should make us good at commercialising more of our research in this state. We've got top universities, more of them relative to other states. We're in the startup hub, Sydney Startup Hub. We have more startups than any other state or territory in in the jurisdictions across Australia. We've got a global city, which probably means a little bit less now we're in COVID than it might have previously, but that's a real attractive feature. In fact, people think of Sydney before they think of probably Australia or even definitely New South Wales. It is really kind of a place where people seek to come and know about, so it has global recognition. And I said to the Premier, I've seen in the various ministries I've held that we do research and development. It's not owned by a particular part of government, a particular cluster, and we need to join this up more connectedly because it's an economic development lever. And yes, we have a hard infrastructure agenda that's led to an amazing $1.6 billion investment into hospitals and to schools and to rail and to road, which, you know, did more than just address what was a backlog in hard infrastructure in the state. But we need to have a kind of creative ideas-based economy as well. And that resonated with her. So she said, well, go away and work up some terms of reference and tell me what you'd like to do. And I assembled an amazing group of people who were happy to come along for the ride that has delivered now in ways that I will explain. But David Gonski, who I've worked with over the years, and I was involved on the council as Deputy Chancellor at UNSW, he and I discussed this initiative over a number of times. And so we assembled an amazing group of big thinkers across industry and sectors. And so now you have the action plan, which, as I said, coming back to where I started, the Premier launched in January. My very strong view was that We needed direction and leadership from the Premier, because this was a primacy that the state had to take around ideas and the power of them, the economic generating opportunities that come from that. It had to be agnostic as to technologies or clusters or agencies, and that we could do so much if we had a joined up approach around that. We never actually had an R&D acceleration plan before, so it was a first. And so from that, we've had some deliverables already, which is very gratifying. In the last budget, the Treasurer and the Premier supported a bid that I made for $24 million, which will support two of our actions, which is around a small business innovation research program, which the US has been successfully over many decades in getting innovative products solving government problems and often creating the first customer for those innovative solutions in terms of being a procurer of that product that solves a government problem. So it works at many TRLs across that scale. So that's going to support what will soon be an announcement around the SBIR and the challenges, discrete government challenges that we will announce. And then also we're creating a matchmaking platform, which is really responding to discussions in the consultations we did, and I continue to hear, including one that we held here, Sydney Startup Hub, going about a year ago, where startups and founders were saying, we don't know where to get skills, we don't know where to get the business expertise we might need, we don't know where the research infrastructure in the state is. And I heard from businesses on the other side, mature businesses, we don't know where to find inside universities the people that could help us solve our day-to-day applied research problems. So the matchmaking platform will be an online platform. It will seek to create that visibility. It won't be curated in the sense that we'll be actively matching parties, but it will at least bring a visibility that I don't think is there at the moment. So that's a complex piece of work to design, and we'll be going out for an RFP on that at some point this year. And then 3 weeks ago, the Premier announced the creation of a group called R&D New South Wales in her Department of Premier and Cabinet, which is under the rubric of Invest New South Wales. So this is the economic development arm of the state, and R&D has an agency inside that. We're only 3 weeks old, so baby steps at the moment. But again, that was a supporting action that we wanted from the R&D action plan to ensure that we had execution. So we had budget, asking for more budget, of course, as you do. But we had to have an executable feature to this plan, because a plan's just a plan until you've got budget and a way to execute against that. So there are other priorities in that plan. We want to work through our precincts to make sure that we have activity that's early innovation stage, ideas based there as much as mature industries investing. We want to work more closely with universities in actually providing them with a roadmap of research that as a state we will back in and strategically follow and argue to federal government for funding. So be a little bit more focused on what we go to the federal government on, being clear on the bid and what the outcomes are going to be. We need to be strategic in that. And then working on something that we've started to do and we need to do more of, which is basically boosting our open data capacity in the government. We've done some really wonderful work of that under the leadership of my colleague, Minister Domnello, as Minister for Digital. But I know there are data sets that are sitting there with the right curation, with the right ability to access. We can actually help founders found new businesses. We can help mature businesses solve their problems. So conscious of time, I wanted to congratulate you all on being here today, on the efforts. One of the other recommendations, which goes to the reason why I really wanted to be here, is in the action plan we talked about supporting more innovation networks. And so this innovation network is one of the exemplars. We have another couple of others, and I noticed that I think you're working with the Clean Energy network that's based at UNSW as well. But it is my desire to find some more funding for other innovation networks that create that industry, university, solving problems approach, which is what we need. And so I'm just so excited that it's purposed to something that I understand the importance and the impact of our environment, the better future, the industry challenge that will be solved by this amazing piece of technology that's a kind of cross-disciplinary approach to solving for our community and for business in that space is just indeed an exemplar of the virtuous circle that we talk about when we talk about a circular economy. So I want to thank you sincerely for giving me the opportunity to speak to you, to say that we love what you do. We want to do more of it, and very happy to engage with you, and congratulations to Susan on leading this up.
Thank you, Gabriel. And I think you can see the power of one individual, almost a network in her own right. Gabriel, you've been a forceful figure in New South Wales for the last 2 years, and we look forward to that continuing and escalating. So thank you. It's an amazing progress in 2 years that a lot of us have been wanting for many. So thank you. We now turn to hear from industry, speaking more specifically about the CRC project. And without further ado, I'd like to introduce our first speaker, Ian Olmsted. Where are you, Ian? Here. Thank you. Ian is from Dairy Australia. He's the Program Manager for Manufacturing Innovation and Sustainability, and has lots of responsibilities, including for manufacturing challenges, collaboration and transfer of technology. A full-time job, any of them in their own right. So welcome, Ian.
Thank you, Parliamentary Secretary Upton, for your opening address. That was really interesting to hear, I guess, just how government is supporting innovation in the state, and really encouraging. Sorry, let me go up a bit higher here. Yeah. I could see that was going to be a problem before I even got up here. Yeah, look, really interesting to hear about what's happening in the state and the initiatives the government are taking to help address and support innovation. That's excellent. And thank you to NSSN and ATSE for the opportunity to provide this opening address on behalf of industry. I was actually reflecting on the flight up here today, and with Jane Paramore from APCO just before this meeting, just how fast things have moved in the packaging and recycling space in the last 3 years. Within my work program at Dairy Australia, we work to support dairy manufacturers to track and improve their performance against a number of sustainability measures. But until recently, packaging discussions were off the table. We really, it was seen as too competitive, too commercially sensitive. Packaging was part of a brand's definition or recognition. However, with the rise of the national packaging targets, we've really seen how this has changed. So the targets have really helped to generate momentum and create a level playing field for companies to start to address packaging challenges and move towards more sustainable packaging outcomes. And we've really seen that the supply chain, the packaging supply chain, are moving forward with confidence. So we've seen a huge amount of work in this space over the last 3 years. As you'll hear about today, dairy brands are already working quite hard to address the challenge of sustainable packaging, both individually within their businesses and collectively as an industry group. Back in October 2018, we actually started an industry working group on sustainable packaging, which has been working together to look at how do we share knowledge on packaging improvements and work together to move the dial on sustainable packaging and meet our targets. One of the outcomes of this work or this network is that we're now working together with APCO, with the support of APCO, to develop a dairy packaging roadmap to 2025, in which we really map out the challenges and opportunities for dairy to address the packaging targets. And through the connections that we've made with this group, Dairy Australia and Food Innovation Australia Limited are supporting a number of projects in this space. So we've supported a project with Bega looking at increasing the recycled content of Hdpe in milk bottles. And we're also working on another project to trial packaging lines which improve the recyclability of the material and also reduce waste within the production environment and also improve food waste outcomes as well. Companies like Chobani are also really playing a leading role with them recently winning an APCO Sustainable Packaging Award. So dairy's doing a lot in this space. As we seek to make progress as an industry, though, it's really becoming increasingly apparent just how important technology and innovation is, and how important the packaging sector are to us meeting our goals. And particularly the R&D that's happening within groups like this. So companies like label makers are doing some excellent work in the labelling space and in schemes to help ensure that the backing materials on labels are recycled and managed more appropriately. And as we'll hear about today too, with the support of the Commonwealth and partnerships between industry, research and technology providers like PEGRIS, Australians are really starting to make some incredible inroads into sustainable packaging. Some of these are really world leading, so it's excellent work. So look, I won't take up more time, but I'd just like to I guess, pass over to the teams now and hear. No, I won't introduce. I'll let you introduce them, but I'm looking forward to hearing about the project. So thank you.
Now we're going to hear more specifically about the CRC project, and without PEGRIS, this would not have happened. So I'd like to introduce Mr. Ian Byrne, technology consultant for PEGRIS, whose background is in industrial chemistry. Welcome.
This would help. So, thank you all for attending today. Industry and science always have problems. Science loves to investigate them. Industry just wants to fix them. And some problems are so vexing that both are needed. This one's not black or white. The edges are blurry. The effects overlap with all companies in the packaging group. PEGRIS is a technical consulting company. We operate in the associated fields of chemistry, industrial equipment, and manufacturing. We have an international footprint and have been solving industry problems for over 30 years. We also have a long history in the chemistry and technology of packaging and labels and how they are constructed. In 2017, Graham Lang, the Group Technical Manager of Label Makers, approached Stefanos Peters, the Group Managing Partner of PEGRIS, about a glue problem and the impact it might be having on milk bottle recycling. So what is the glue problem? It relates to the glue sticking the labels to the milk bottles made out of Hdpe, high density polyethylene. A milk bottle, which I have my... The label is only about the thickness of a human hair and consists of 5 separate layers. As consumers, we only notice the images and words of the ink from layer C. But the heavy lifting has been done by the hot melt pressure sensitive adhesive that glues the label to the bottle. The glue is very hard to fully wash off when the milk bottle is being recycled. The current global best practice for food grade Hdpe recycling enables a reuse of about 25% of recycled content, combined with virgin Hdpe that has a zero glue contamination to form a new milk bottle. Any higher and the residual glue contamination from the recycled component impacts the bottle production and quality. If we look just a little closer, we'll see in the first image there's a cross-section of the label stuck to the bottle. At 100 times magnification, you can see that the glue line is less than 2% of the whole construction. And if we look at the 2 times magnification, we can see this defines the problem. The glue does not want to let go. APCO is leading the packaging industry to meet the Australian Government's 2025 national packaging targets of an average of 50% recycled content. The aim of this project is to increase the recycling of plastics by sensing and treating label contamination and contribute to that effort. Reaching this target requires an ongoing collaboration between industry, government and universities. PEGRIS, as the industry lead, is partnering with the NSSN as the conduit to the university research teams. It's taken over 4 years to reach this point. We have focused on only one plastic, natural HDPE, predominantly used by the dairy industry. However, our findings will transfer to other plastic types. Sydney University has developed a world-first method for sensing residual glue levels on recycled HDPE, plus new wash chemistry and a surprising application of physics to label delamination. The University of New South Wales has used a supercomputer to model and understand the forces governing the washing process and designed a laboratory test rig that will be fundamental to label innovations. The University of Technology Sydney will provide a first-time view of material flow analysis of milk bottles in isolation. The ATSE report towards a waste-free future, in recommendation 2, 4B, has provided guidelines that are being applied by label makers in designing labels for recyclability. They are reducing label complexity, they are using material innovation, and it is all designed to increase the removal efficiency of the label and the glue. In cooperation with Telford Smith, they have been testing this in an industrial full-size wash reactor. Using world-first test methods, the washed HDPE is analysed for residual glue. The results are assessed, the label design is modified, the process is repeated, and the target is zero residual washed HDPE. This involves significant resources and time, and only one trial variation. Label makers have now designed 4 variations, printed 80,000 labels, made 40,000 of these to stick them on, and Telford have used over 4,000 litres of wash solution to remove them. The initial results have been spectacular. One label variation, reducing the glue residual by more than 40% below the standard. The speed of the design cycle needs to be increased. Label makers will be transferring their testing to a project test rig currently under construction. Use less, test faster, and repeat. All parties in industry and universities have been working extremely well together in addressing a clear environmental need, in collaboration with the government CRCP grant program. Businesses can benefit from expanding their R&D efforts to amplify local production efficiencies. The project has been a success on many levels that will be detailed in the following presentations, commencing with UTS, providing the context for why we are here today and the targets we'll need to achieve. Thank you.
Well, let's hear in more detail the reason why this project has been so successful. I'd like to introduce Dr. Melita Jazbek from UTS, who specialises in resource energy and waste futures. Welcome.
Good afternoon, everybody. We are situated at the Institute for Sustainable Futures at UTS, and the Institute has about 50 research staff and 50 postgraduate students. We often partner with government, industry, and community to address complex sustainability challenges through transdisciplinary research. And we work on more than 150 projects per year. What I want to start to talk about today first is to have a look at the whole packaging picture. What you can see from this graphic is that 50% of the packaging that is placed on market finishes in landfill. 11% of that packaging would not be able to be ever recycled because it's not designed to be recycled. And what is, just to point a few other takeaway points here, is that 31% of the collected material is not, the 31% of the material is not collected. What it literally means is that the items you should have placed in the yellow bin have finished in the red bin. So of the material that has been recycled, about 50% is exported. If we look at what happens, in 2016, more than 50% of the world plastics waste collected for recycling was traded internationally, and that applies for Australian plastic exported too, within Asian region, and 1/3 of that went to China. However, with the introduction of the China sort restriction, that has shifted towards Southeast Asia. And Southeast Asia does not have nor capacity nor capability to process this low-quality recycled material. I should mention that China still accepts high-quality recycled material, however, not the low-quality one. And a number of trade restrictions have been put in place to address this material, which often finishes in the environment and also as a marine plastic pollution. Australia has also introduced an export ban, which will impact 32% of the exported material, of which 13% is plastic. It will impact predominantly, in the first phase, it will impact the mixed plastics, as you can see in the picture, which will not, from July this year, nobody will be able to export that any longer. In addition to the ban, we also have committed to the national packaging targets. As you can see, we are progressing quite well in going towards achieving 100% recyclable and reusable packaging. However, if you look at the second target of 70% of Australian plastic packaging being recycled, we have a long way to go. And also, while the recycled content, 50% of recycled content average target appears that we are on track as well, if we focus or zoom in a little bit in plastics, we can see that with the Hdpe only 3% is recycled content. So our team at ISF, what is doing for this project is taking a big picture, like a system thinking approach, where we're trying to identify how could we increase the Hdpe recycling, and also how could we transition to a more circular economy. In this graphic, it's illustrated the supply chain of Hdpe and the areas where you can address along the supply chain the packaging targets. And in addition, at the bottom, you can see the material flow of the rigid Hdpe packaging, which includes, in addition to milk bottles, also shampoos and other cosmetic bottles and chemical bottles. And what is striking is that 73% of that is lost during the collection process. This project, however, focuses mostly on the milk bottles, which come in different shapes and sizes, however, predominantly the 2-liter and the 3-liter bottle. We have used the Dairy Australia milk consumption data in label makers, bottle weight data, and previous APCO work to evaluate what is the distribution among the states in terms of Hdpe on the market. And you can see that in the map. So as Ian has pointed before on the Hdpe bottle, it's made from, the milk bottle's made of Hdpe. The cap on the top is low or high density polyethylene, and the label is either polypropylene or PET. The aim is to remove the label, remove the cap, and get the clean products at the end, which is, you can see in the picture, the natural Hdpe recovery, the flakes. That's where we would like to get. But when we look at the system, we see the collection losses are much lower for Hdpe milk bottles. So we do know that milk bottle is recyclable and we put it in the right bin. However, after it's sorted, most of it is exported as a milk bottle. Now, that will not be any longer possible from mid next year when the second phase of the export ban comes in place, and we will be aiming to achieve the recycled flakes rather than that. Looking at that, you can also see that we've got a long way to go in terms of there is to increase that capability. But interestingly also is that 74% of the recycled HDPE has been locally used. Now, the bad news for circular economy is that most of it has been downcycled into industrial applications instead of being recycled to like back to the bottle. So what does it mean? What does plastic circular economy mean, really? So we want to improve the management, so we want to increase the collection, we want to increase the separation, we want to increase the recycling. But circular economy, it's not just about recycling. It's also about reducing our waste. It's about reusing. It's about keeping our materials in use as long as possible. It is also we want to decouple our connection to the fossil feedstock. And what are the pathways to get there? One of the first obvious one is to eliminate on all non-recyclable materials and unnecessary items in packaging. And we want to expand the reuse options. And also we want to design that in the case at the end of life, that material can be either reused or recycled, and not recycled just in one state or one country, but globally. So recycling, to increase recycling, improving the technology is one of the approaches. However, there are many more ways that we can increase recycling. And here is just a couple of examples of the best practice around the world. So there is a little project called Holy Grail where they are using chemical tracers or QR code, which we are all familiar now with COVID, to identify, which is on the label, so we can identify what the container is made of, where is it come from, what was it used for food application or not, which could help in terms of increasing the recycling of the food related containers. There are also other measures like the plastic packaging tax that UK is introducing in terms of taxing all the material that has been has less than 30% of recycled content, which has been either manufactured in UK but also imported, or addressing the lost plastics to the environment and getting those caps to the recycler rather than losing them. EU has introduced tether caps and lids, so the caps are going to be attached to the bottle until they come to the recycler. Another way to increase our recycling is also the demand and expanding the markets. There are barriers about inconsistency in the quality and of the recycled material compared to the virgin material, and low cost of the virgin plastics due to oil prices. However, there are also a lot of opportunities. And in introducing standards, introducing policies and measures like landfill bans and levies will all contribute to increasing our recycling. And as you can see, the mixed plastic bales are worth nothing. If we can separate them into the milk bottles, we get $500 per ton, but if we recycle them, we get $1,200 per ton. And University of Sydney is going to explain a little bit more about how to get there, and that's the processing is the step in the supply chain that they are focusing. I'd like to thank everybody on behalf of our team, Nick, Ben, and Damien from Institute for Sustainable Futures.
Thank you very much. And Damien was also a member of the expert working group that put together the ATSE report. Turning now to another key figure in the project, Associate Professor Brian Hawkett, who is is the director of the Key Centre for Polymer Colloids at the University of Sydney.
Here we are. Solving problems with recycling HDPE milk bottles. And the people listed there have been, 3 of them are here working the table over there, showing people what we've done in reality. And I'm Brian Hawkett down the bottom. This is our group, because I thought I should say a little bit about our group and what we've done. We've been working with industry for 22 years. We've been working with ARC and Dulux Australia for all those 22 years continuously. For Dyno Nobel, all those 22 years continuously. We work with Certex Medical on nanomedicine, and some of their products are now undergoing first in humans trials in hospitals around Australia. I've worked with the US Air Force on space propulsion and with Syngenta Agrochemicals on delivery systems. Going on to our project here, which is recycling milk bottles. The milk bottles come in this sort of state in bales. They're contaminated with dirt and odd bottles that don't belong there, and caps and labels and all of those sorts of things. They first undergo a crude washing and sorting process. The coloured tops and retaining rings are ripped off, and the bottles are chopped up into what we call HDPE flake. They've still got the labels on, and they are then, the flake is washed in a caustic solution containing solvent and surfactant with the objective of removing those labels. And we need to test for the contamination or the residual impurities in those flake, and the current test is fairly qualitatively, i.e. does it stick to your finger? But it doesn't give you an accurate quantitative test result, but it indicates one thing that is not good, is that the glue has permeated all through the system. Going on a little bit further, glue and label contamination are the thing that we've got to overcome when we're recycling these bottles. 12.5% of the milk bottle surface is covered with a label material that's stuck on with pressure-sensitive adhesive. If we try to wash the adhesive off the flake, the adhesive permeates the entire system. Here you can see that label there, which is a multi-layer thing, as as Ian said, and the glue where we're trying to pull the label off the HDPE, you can see the glue here. And first of all, we need a QC method that yields an accurate measure of the glue contamination, and we need to find a way to get rid of the glue before it can permeate the system. So we've come up with a new sensing technology to determine the glue content in the recycled flake. This is something that we can't tell you a whole lot about, but for example, recycled flake seems to come out at around 0.25 weight % glue, We have a provisional patent on this test method, which is why I can't say very much about it, but the method takes into account the non-uniform nature of the flake. And I think here we will see a sample here of flake that has been washed and recycled. And the things that you notice in the flake here, that there's still some bottle caps and retaining rings and the like, but there's also still a few bits of label stuck on some of these flakes. And as you might realise, the label that's still stuck on the flake has got the glue on the underside of it, and that's still retained in the system. So we can separate out bits of flake that have got labels still stuck on them, and we can separate out the caps and the like. And what we found was that there's 85% weight of the flake without labels and without caps, and that contains about 0.25 weight % glue. So this is there where it shouldn't be. It's got all over the clean flake because it's been dissolved up in the system and washed around the place. Washed flake with attached labels was 14 weight %. Now that, because it's captured the glue underneath the labels that are stuck on, as a higher value, it's about 0.7 weight % glue, and then there's 1% of the caps and rings and such like. Now, solving the glue problem. The big problem is to remove the labels and glue without contaminating the whole patch with the glue that you've taken off the Hdpe. Present practice tries to dissolve the glue and wash it and the labels free. This causes the adhesive to permeate the system, have a drastic impact on the recyclability. Commercial, and we've seen that number before, 0.025%. Now, the question I've asked here, is it possible to remove the glue without dissolving it? And from there, we go on to a process that is called impact delamination. Now, impact delamination is a problem for laminated construction materials, particularly noticeable in the aircraft industry and in the construction industry. If your aeroplane hits a seagull, for example, it puts an impact there that can cause the component to delaminate. And the components of a laminate can respond differently. They've got different rheological properties, and when the impact comes, they behave differently to the force. And this can cause them to, well, fly apart. And we've tried to make use of this, positive use of this, which is normally regarded as a destructive phenomenon. This is encapsulated in another patent which we lodged in May 2020. The concept has been proved on a laboratory scale, one bottle at a time. Further funding is needed to really put this into a factory. But if you look at the little diagram here, it gives you an idea what impact delamination is. And you can see that when that blade hit the laminate, the forces was distributed in that laminate in such a way that the laminate came adrift, so your glue and your label came apart from the Hdpe underneath. And this shows potential to be able to get rid of those components of the laminate without actually dissolving it up and getting rid of it. Now, and this is, here we see the glue content in a delaminated sample before washing. So we haven't washed this sample that we're talking about. You start with a piece of Hdpe here, with a label on it and the glue sticking the label on. We impact delaminate it, and you can see all the labels that are fluffy and loose there. And then we separate that out. You can separate it off by blowing it away almost. There's still a couple of little bits of label on there. And then we've got relatively clean Hdpe. And when we look at, when we measured the glue content in this, we got a value of 0.08% without washing it at all. And we compare this to the factory getting 0.25% after it's been washed. And that doesn't include the little bits with labels on and that sort of thing. So we seem to have made a real improvement. We haven't got down to the 0.00 where we would like to be and have pristine stuff. Well, you know, so we need to wash it to get that little bit of last stuff out. And how do we do this? We have to have a washing solution that hopefully doesn't spread the glue through the whole system. So what we've devised here is a washing solution that at low temperature, you can see it's an emulsion here with the glue all through the body of the solution. But when we heat it up, the glue, emulsified glue will phase separate from the washing solution, and we can skim that off the top and use the washing solution again. So that's got potential to get that all out of the system. And just to sum up what we have, we've got a QC method, which is, they tell me the first for doing this, for measuring the glue content in the Hdpe, and we've got a provisional patent being prepared. We've got a new mechanical separation technology is under development based on the impact delamination, removes most of the labels and glue without washing. A new chemical washing technology has been developed to remove most of the residual glue from the commercial Hdpe feed. Both the impact delamination and the washing solution are the subject of an Australian patent lodged in 2020. And thank you for your attention.
Our last presentation, the final piece of the puzzle, is Yanshong Shen. Welcome. ARC Future Fellow and Director of the Process Modelling and Optimisation of Reaction and Separation, or the Promo Lab at the University of New South Wales.
Thank you, Susan. All right. Hello, everyone. It's very a great honor to be here to introduce our work in this CRCP project. So in our part, basically we try to use the computer models to understand and to optimize this washing process. So this is the teamwork. Dr. Shuya Li sitting somewhere in there, and Dr. Yuting Zhou are the team member of this work. So basically, Brian had already gave a very brief introduction about this process. So just let me briefly repeat this. Basically, in this typical plastic recycling process, we need to first collect from our yellow bin, like Susan did every 2 weeks now. And then we need to sorting them out according to the types and the color. And then we need to grinding them into pieces, like Brian just mentioned. And the key step will be washing after, followed by drying. And washing will be the key step to, let me find the button, yes, to separate the label from the bottles. So this process should be understood, sorry about that, should be understood and optimized in terms of efficiency and cost. So in this process, basically in industry, as you can see from in the presentation, this reactor is 3 meters high. it's basically large-scale chemical reactor. So basically, it's a very important. It's very difficult to access the internal phenomena. So and also it's very expensive and risky to run the plant test or even the pilot test. So our strategy. So basically, sorry, let's say it's basically the washing reactor, and we can see gas phase, liquid phase, and we can see the flakes inside. That's a solid phase. So this is a very complicated chemical process. So our strategy, we will not need to run the real plant test. We will not do that in the real plant in the label maker. What we hope to do, inspired by the digital twin concept, we created this mathematical model. This model will be the replicate of this real industry process. And this model will be the same as this industry process, like 3 meters high and high temperature, and also with the complicated chemical processes. So using this model, we can understand this process, we can optimize this process at a lower cost, and also it's a risk-free. We will not touch the real plant test. So plant operation will not need a stoppage, will not be touched at all. So the key deliverables in this process, in this project will be first we deliver this model, and then we test new designs, like impellers, like baffles, like these tank geometries. And then we can use our laboratory test rig with a poster outside. We can do the concept proof and also model validation. And deliverable 3 will be we can deliver some optimal design based on our simulation results. And finally, we can deliver this industrial scale model to industry, and industry can hand over this model. Industry can just do their research. So basically, it's a kind of a lift up of an industry research capability. All right. So sorry about bringing this slide up. Basically, we need to set up this model. We need to set up this model. So basically, this is a mathematical model. So we need to do that within 3 steps. First step, we need to do the geometry. So basically, we need to create this geometry. And second step, we need to do meshing. It's a kind of one key step in the numerical simulation. And third step, we need to set up this, develop this mathematical model. So here I list some key, we call it governing equations. Sorry for the typo error. Governing equations, basically it's based on the momentum balance, heat balance, and mass balance. So this is not a mathematical tutorial, so I'm not go to details. This is the initial conditions we need to follow with sorry about that. We have a gas phase and solid phase and liquid phase, and the temperature will be 85 degrees, as Brian just mentioned. High temperature operation will be very great for the high efficiency operation. So our question will be, can we use like a lower temperature, for example? Can we test other designs? So with using this mathematical model, we will be able to do that. So we have the model. Now let the model give us something feedback. Okay, result 1, the model can help us understand what's going on inside this chemical reactor. Okay, here we can see the one key phenomena can be captured. This is a surface vortex formation from 0 second to 200 seconds. We can see how the vortex can be formed. So without this numerical model, basically we cannot see that, because in the real chemical reactor is a high temperature process and it's a closed system, so it's impossible. But using this numerical model, we can do that. And also another key phenomena can be captured. That's flakes drag down process. We can see the flakes in here at the 0 second and gradually can be dragged down. This is the typical process in this chemical reactor. So basically, using this model, we can capture that too. So basically, this model can help us understand this process. And also, this model can give us much more details, like the velocity details, like the turbulence kinetic energy distribution, like the mass transfer rate. And also, we can see the velocity distribution between the impellers. Very detailed information can be provided using this model. And also we can generate some diagram to understand the time evolution of the flake mass flow rate and the contaminant level as the outlet. So basically, they can help us to evaluate the overall performance of this chemical reactor, not just in internal state, but also the overall performance. And let's result 1, we can understand what's going on inside. Result 2, we can also use the model to run some virtual test. Okay, virtual test, numerical experiments. We will not touch the real plant test. We will not touch the real chemical reactor. We just using this model. We just use this model to test our designs. Like our collaborator Brian from CNU have some new ideas about the new chemicals. Okay, industry may not allow us to test that in the real operation. Graham, it's a bit risky and may need a stoppage. So using this model, we can test these new designs. Here I use one example. We test several rotation speed. For example, 250 to 300 RPM, revolution per minute. So because this is the numerical experiments, we can run as much as we want, all right? So here we can see, compare 277 to 300 RPM, we can see how the vortex will be enlarged, which is not good. I would say that's the negative side, because larger vortex means less effective area. And also we can see some good side, like the turbulence will be much stronger, all right? So, and also we can have a look at the optimizing, like a washing efficiency. We compare this different rotation speed, and then here we can see 277 RPM give the best day contamination performance. And basically this model can tell us the performance of one new design. And also we will have more to test, like temperatures. We are using now 85. Can we use like 60? That will big save of the energy consumption for the industry. And also we can test new like impeller designs and blah, blah. With this model, we can do a lot of stuff. All right, I guess that will be all. And last slide before we finish. This slide summarizes what we are doing right now in my lab. The lab is called Process Modeling and Optimization. We are working on the like a low run coal upgrading and the steel industry, and also the clean coal combustion, and also the particle mixing in the food industry, and our plastic recycling is in here. And also we are doing the hydrogen-powered iron making to enable the net zero emission in the steel industry. You know, steel industry is one of the largest emitter. And also finally, the message for you to take home. We are working on computer models, and the model can help us to do the process understanding and design. In collaboration with industry partners, we are looking forward to contribute to the Australian circular economy. And let me use this, use this figure to conclude my presentation. Basically, this is from President of the Australian Technology, Science, Engineering, Professor Brackhilder. And he mentioned in one presentation, university researchers should work together with industry, because either we can come up with some big ideas, because we just look down in the lab, we cannot come up with big ideas. Or more importantly, we can solve the real problems in industry. Thank you.
Thank you very much, Yan Song. We've been treated to an example of human ingenuity being on steroids when we all collaborate. So the other three, where did he go? You disappeared. All four speakers up to the chairs, please. I'll ask one question from the audience, and then there are quite a few coming up on the screen. So any burning questions from the audience? Paul Scully Power.
It's a very simple question. Why in this day and age are we still gluing labels to bottles? For example, if you go buy bottled water the label's not glued on.
Okay, I'll give you the floor, Brian.
No, so small bottles, you're talking about round bottles, so then you can put a label around it. This is,
Square bottles.
yeah, square bottles. If you put a label on, you need much more label to do that, because now you have a small label, and if you need to wrap around the whole bottle, you need much more material to do that. And it's a square bottle, yeah. So that's one of the explanation. But I think with this program, we can solve the issue. So.
Just a subsidiary one. Have you ever heard of lasers?
Okay, I'll just ask one question from the screen here, but it really relates to how to make the economics work. And you've talked about scale up of the benchtop optimized system that's been developed during this project. So what do you see as the path forward to getting this to scale, to commercial scale?
Itself is providing a tool. As I said in my presentation, we had 4 variations, and one of those variations reduced the residual glue by 40% against standard. The problem is 4 trials, a lot of material, took a lot of time. So the aim is to be able to have a methodology. One, you had to be able to measure it, and that's had to be developed, so that's been developed. And then you need to be able to repeat those trials over and over with other variations. So you may not need 4 trials, you may need 400, but you can't do that in a commercial environment. You've got to be able to do that in a faster iteration. So we've built a test rig. But you also got to make sure that that test rig can be, is basically repeating what's happening in the real world. And that's where the New South Wales came with their model as well, to make sure that the system that you're running there reflects what's going on in the real world. So it can actually improve the current system by just a better label. So everything else stays in place, the $1 billion worth of infrastructure stays in place, and then you just tweak one component, the weak link.
Okay, thank you. We are out of time, and Lisa McLean is going to dig a little bit deeper into this, and I should introduce Lisa, who's the CEO of the newest New South Wales government network, New South Wales Circular. So welcome, Lisa, and I'll leave it to you to introduce your panel. But please please join me in thanking all 4 speakers who've presented the results of the CRC project. Thank you.
Thank you very much, Susan, and also to Parliamentary Secretary Gabriella Upton. I'd like to commend the work of our sister network, NSN, and ATSE in solving another key problem for the circular economy. And we've got a lot of barriers to remove to make that transition. But we've got some fantastic people to hear from. So could we have Mr. Graham Lang up, Ms. Jessica Walters, both from label makers, Professor Thomas Maschmeyer, and also at Van Dyke from Bega Cheese, rather, Bega Cheese Limited. So it'll be good just to do a bit of a deep dive and hear from their perspective on this fantastic project and how important it is to bring together research and industry. It wouldn't be possible to remove these barriers if we didn't work together in this way. So I might start with you, Graham Lang, from Label Makers. You've been at the heart of the project. Can you tell us about your work and why it's so important? I might just hand you the mic if we can.
Yes. Look, background-wise, and I guess how I became involved in this project, probably spent 40+ years as a technologist across the packaging industry. The last 30 of those with label makers, and initially set up the division that makes our own pressure-sensitive label material. I guess the material that's in question here. And so, look, it was probably a visit to the Visy recycling facility 7 or 8 years ago when it became apparent that, bad material design from a label point of view, although it's a minor component of the waste stream, was having a pretty significant effect on the recovery of the thing that it was stuck to, the plastic bottle. And so, you know, in many ways, felt a strong obligation there because we were the predominant supplier. And you know, I remember looking at those bales that we saw before of compressed Hdpe bottles, and I couldn't see a label that wasn't ours at the time. And so, you know, roll on a few years, meeting with the guys from Pagras, Stefan and Ian, discussing some intelligent chemistry, I think, that was being used to clean some printing equipment, and look to see how that might assist us with this issue that we had of removing, you know, label contamination and adhesive contamination out of the waste system. So yeah, I guess my involvement with the project was the seed at the beginning, kind of an ongoing situation within the project itself. You know, as we've seen, we were able to provide a lot of the information because of our industry position as to the scale of the problem that we were dealing with nationally. Insights into the kind of materials and chemistries that were at play. And yeah, you know, we've as we saw with the Telford Smith example, done some CITA trials looking at different materials that might, you know, kind of give us a head start in the recycling, in the removal of labels and adhesive.
Thanks, Graham. Jess, can you just tell us, you know, what were the drivers in taking on those challenges? Graham's elaborated a little bit, but can you talk a little bit more about this?
I think there's a few things. Certainly our involvement's multifaceted. I think as a label manufacturer, we certainly recognise the important role that the label plays in the recovery of the container. I think 1%, the label represents about 1% mass of the total pack, but is actually impacting the 99%. So I think we firstly recognise that, and we need to take responsibility for the waste that we create, but also recognising that the label plays an incredibly important role in not only brand, but also in communicating nutritional information to the consumer. So it's it's necessary in the pack. We just need to, as the points have been made today, deal with it in a smarter way. I think the other part of this in terms of the responsibility, and Graham, you alluded to this, is the fact that from a brand partnership perspective, we are close to supplying, manufacturing nearly every milk bottle or milk label in the country, bar a few. And with that comes some responsibility. Also, that brings great insight into the volume usage nationally, but also the material specifications that are being used at an industry level. And both of the volume and the specification IP has been incredibly important as an input into this particular project as well. So certainly Graham's IP on the adhesive development side, and then also the understanding, I guess, more of the market. And I think the other part of the responsibility comes with the fact that we are uniquely placed in Australia and New Zealand because we're the only label manufacturer and manufacturer of pressure-sensitive label materials. So what we really hope to gain from this project is taking the technical insights that are being learned and shared, and actually translating those into a label solution that we know is aligned to the recycling supply chain in Australia. So effectively, we're starting with the answer, and it's recycling led, and then we're working backwards from there. And there's a huge amount of work going on in our business from an R&D perspective in taking these learnings now already and starting to develop solutions in this space. So all of those things are incredibly important. And I guess my role specifically in this is one of education. So once we, I guess as I'm acting really as a conduit between the brand owners and then the project and the research outcomes. And there is a big role there to play then in terms of educating the customer base around, you know, what are those learnings? what are the best decisions to be made from a label selection material point of view. Because ultimately what we need to do as an industry is not be developing customised solutions for every brand. We want, ideally, to develop one industry solution that we know works through the recycling supply chain. It gives everybody economies of scale. We can produce it at a price point that is neutral, so actually to make it a sustainable solution, but also a commercially viable solution too. So all of those aspects are really important, and it's not just about educating consumers or the brand owners, I should say, around the material selection. There's also implications for how you graphically design your artwork that goes onto the bottle. So why are we flood coating label materials with white when the background of the milk is white? It just helps in terms of the recyclability of the total package if we're thinking really holistically about all of these things. So the implications are really widespread. And as I said, it's not just about the technical aspects, it's also then talking to the marketing teams and the brand teams and rethinking about how we're designing labels for milk to really contribute to the overall recycling challenge.
Yeah, and position yourself future-facing.
Absolutely.
We might go to Ad now just to ask about the role of Bega Cheese in the dairy industry and how you took this forward and what's sort of important out of this project for you.
Yeah, so if you look at of course, the whole milk bottle, there's the bottle itself, there's the label and the cap. So the bottle itself, I think the Hdpe is very clean because we're in all the milk industry. And by the way, I'm talking not only for Bega, but also Saputo. There's also and Lactalis who are supporting this project. Very important, by the way, that this is a collaboration which was led and came out of the industry group of Ian Olmsted. I want to mention it as a starter. So I think very important is the collaboration between the industry and funding this project as a starter. So the milk bottle itself, Hdpe, very good material, very clean, you can recycle. It's recyclable. I mean, we have Austin from Martok in the room here. These are trials already. Can we recycle? Absolutely, we can. So the bottle itself is very good recyclable. The label itself is causing issues. Why is it causing issues? Because of the glue on it, and we have heard about it today. So one question already earlier, why the heck do you use a label? Why do you need a label? Well, we need to keep label makers in the business. That's what Graham told me. He said, don't go out of business here, so we need to help this poor man. But I think that you need to understand that in the milk bottle industry, when we put the label on, the environment is hostile in the sense that if we fill the bottle, it gets into crates, it's in a wet environment, 4 degree warehouses and things like that. The handling is not very simple. So you need a label that sticks on it to be able to see what is inside the bottle. And you don't want to, you buy your milk, you want to know what is inside. The nutritional information has to be in it. So that's the reason why we need the label. But we also know that the label is contaminating in the end if you recycle what we heard today. So I think, so that's our interest. We need to also, as an industry, of course, meet the targets which we want to do in the future and working towards that. So I think that's what it's all about. So we resolve this one for a clean Hdpe, which we can recycle. Let's be very clear. And I would like to say something more is that, of course, Hdpe bottles today, the weight of it, also Bega has worked for the last 2 years reducing the weight of the bottle, which is about 45, 46 gram in average. We're manufacturing 38 gram at the moment. So we have taken a considerable hit in reducing, as mentioned before, which is reduce first. We have done that to get less plastic in the system. Yeah. And plastic is a great material, by the way. I think we have all saying it's very bad. It's absolutely not the case. Everything around you here, the chair, the carpet, and everything is plastic. It's a great material. And it's the lightest material you can have for a milk industry, which is using the bottles over and over again. We're consuming our bottles, buying twice a week. The rotation is a lot. So you need to have a material that's very light to carry your milk, which is reducing your transport cost and all the other costs. So it is the right material. It is the right material working with. We just need to enhance the whole recycling of it.
Great, thanks, Art. Well, we might just go to Thomas Maschmeyer, Sydney University Fellow of ATSE, to find out what makes for good research collaboration with industry. Thomas, in your experience?
Oh, thank you very much. So this is the first time I've sit in such a dairy-focused panel. So I think I should try and milk this opportunity. Sorry,
You've done this before. Do you like it?
Yeah, hello. So I think what is really important, and I think all of you said that word, used that word, that's target. I think it's really important to have targets, and my target has just left the room, I think. There we go. So government setting targets is really, really helpful, both for industry and for the public research sector, because we can coalesce around that target, because it helps us to define problems and it helps us to identify business cases and business opportunities for growth, for jobs, for delivering against the target, which hopefully is designed to give us a better environment or some kind of positive societal impact. So targets are really, really important. And then in terms of the system itself, if there's a strategy, a wholehearted strategy that supports implementation of those targets, especially around collaboration, if that's our point, then that is really, really helpful. And I was going to say some nice words, because I think Gabrielle Upton has done a really good job in trying to come up with a framework for support of implementing these sorts of targets. And we heard a little bit about this before. So that's really refreshing. I think what is also a third point, and then I'll stop. A third point that's really important is an appreciation by, especially, I guess, government to some degree, but also university industry knows already, the timeline and the cost associated with changing something. It may be as simple as a label with a bit of glue, and you think in your university lab, how difficult can that be, right? Bit of plastic, bit of glue, I can just cook up something as a chemist and off I go. It's got to be validated, it's got to be verified, it's got to be tested, it's got to be, whatever production line you have needs to be adjusted. Certifications need to be obtained. It needs to be scaled. Each of those steps have science steps, have engineering steps, have marketing steps. All of that is a big, big picture that costs a lot of money, and it takes a long time. And sometimes when I get, invited to apply for a program, yet another co-funding opportunity by government for, I don't know, $20,000 or $100,000, and it's supposed to solve something really big and really important really quickly, it's just not going to happen. So it would be much better to have a framework that supports those targets in a more realistic fashion. That's it.
Excellent. Thanks, Thomas. We might go back to Graham, actually, just to talk about those key technological breakthroughs and what they were, and if you can explain that to us.
Sure. I guess, we've had presentations from University of Sydney and University of New South Wales that have explained in some detail what's been done, but so I won't kind of go through those again, but I think the enduring things, and it kind of reads on to what Thomas said, I think the really enduring outcome of this project is that there has been created a test facility that allows us to evaluate. As Yan Song said, you can't do this in an industry situation where the feedstock, the waste plastic, is so disparate. This has given us a means, I suppose, of measuring the outcome of a particular speed, a particular washing solution, a particular adhesive, a particular face stock. I think that's probably the most enduring thing. We haven't completely solved it. We haven't completely eliminated the issue of contamination here, but we've got a means to measure now. And similarly with the work that Dook and Brian have done, I mean, I know there's some, and I think I cleared this with Brian, I know there's some kind of IP and patent considerations around this. So, but a quick and accurate spectroscopic way of measuring the adhesive contamination in the flake is really important, rather than, you know, the protracted gravimetric means by which you measure the adhesive content. I think that also forms a really important platform for us to do further work. And yeah, you know, the test rig plays into that as well. So I think they're the two most important things. You know, there are a lot of kind of international standards that exist, and from my perspective, they're all a bit go, no go. You know, this is okay, this passes, this fails. There is a continuum here. You know, we take another 0.5% of the waste adhesive or the contaminating adhesive out of the flake. That's 10% more plastic we can put into the recycle process. It's not a go, no go. And I haven't seen that in the EPBP standards. I haven't seen it in the US APR standards. Now I think we've got a way where we can, you know, quantitatively assess the HDPE that we're recovering and adequately or appropriately deploy that back into new applications, hopefully back into the application that it started with.
Thanks, Graham. That's probably a good segue, Jess. You talked about the drivers before, but what are those broader benefits for label makers and obviously industry from a project like this and research like this?
Well, I think for a long time, up until recently, I think the question that's been asked of us is my label recyclable? And I think we now really understand it's just the wrong question to ask. And in fact, we can't answer that question with any level of accuracy without actually taking a very holistic view of the total packs. It's not just about, is my label recyclable? It's, well, what container is it going onto? And then what ink system is being used? And then what recycling supply chain is it moving through? So the response to a label material going onto glass is going to be very different because there isn't a washing process compared to what it might be for plastic. So it's really about the collaboration allows us to understand every aspect of the supply chain that's going to provide the benefit here. So from the collaboration from that point of view is great, and also from the perspective that, again, we're trying to create an industry solution here, not individual solutions for different brands. So yeah, so I think it's incredibly important that we're taking this holistic view.
Yeah, okay. Thanks, Jess. Ad, what about the dairy industry benefits there?
Yeah, so the main benefits, of course, is that in the end we want to use the recycle Hdpe, and it's feasible. We have done a trial on that and testing, and we can recycle at high contents milk bottles, which is great news, by the way. It's happening in UK at 30%, as you saw. Reason for that is availability. So can you do more? Yes, you can. So I think the story is very positive there in what we can achieve in terms of recycled content. The main, of course, it needs to be affordable as well. The recycled Hdpe that we're going to buy has to be affordable. And today, we're starting to, get some companies in Australia that are starting to manufacture them. And the main issue today is the label contamination. That's why we're talking here about it. And is the glue in it. The glue in it is contaminating the flake, which is increasing the cost. So efficiencies of recycle plants are about 40% now due to labels and glue. So as soon as we get that number up, of course, the price of recycle will go down and the usage will be more. So we need to get in that momentum that we have less, labels, less glue into the recycle content, which allows us to use more.
Yeah.
Which is affordable. And as you know, a bottle of milk is not a premium that you buy. It's really at cost. The margins are not very high, I can tell you that, from the dairy industry. So we need to keep the cost low to stay in the market. So yeah, that's a driver for us.
Yeah.
If I could perhaps just add to that point as well, I think when we talk about industry solutions, I mean, that's what feeds into that, because we do really need mass movement in one direction. To achieve these economies of scale, because what we do need, as you said, we're in a very price-sensitive category, and in order to make these solutions a reality, they do need to work. commercially as well. So that's incredibly important. And again, that's why we need the economies of scale in single solutions to make that a reality.
Yeah. Thanks, Jess. Thanks, Ad. Thomas, can you tell us what are some of those key challenges on the horizon in waste and recycling, do you think, that require good collaboration between research industry and government?
Yeah, so just to sort of move away for a little bit from dairy and plastic, I think in terms of recycling as a whole, worldwide, not just Australia, regulation is lagging innovation. And we hit problems in terms of having recycled materials not treated as waste, but recycled materials treated as virgin input into products which are just indistinguishable from current products. And there, I think a collaboration between the research sector, between industry and government is very, very important to give direction to the regulators. Because I don't think anybody has an interest in bad regulation, for short-term profit or whatever. We want to have a well-regulated society. But well-regulated means also regulation that takes into account the very fast improving and evolving technology. So that's the first one. Then in general, I think the circular economy is, of course, what everybody's been talking about. And if you look at how many planets of stuff we are currently using, it's about 1.8 planets. And if everybody wanted to live the way we do, here in Australia, we need about 6 to 8 planets worth of stuff. So we haven't got that. We only got one, and Mars is a long way. So therefore, there's only one rational answer, and that is to reuse what we are using. So it's not rocket science. And so then the question is, where are the lowest hanging fruit? And now I'm coming back to plastic, because that is such a fantastic material. It is safe, it is light, it is cheap, it is reusable, and certain types of plastic can be very well recycled, like what we hear now, our milk bottles. We just got some issues with the glue, but I think we are on a good way to solve that. End-of-life mixed plastic are really difficult, because in mixed waste recycling facilities, those thin films are difficult to separate from paper, in a sense, because mechanically they're very, very similar. So a company, and I won't bore you with it too much, but a company I set up, Lysella, has got a demonstration project with 2,000 households in Hornsby, where we collected thin film plastics and gave councils a plastic bag into which they could put these films, and they went into the normal trash. And then the mixed waste recycling company that we collaborate with, IQ Renew, was able to just optically sort that bag, which made their life a lot easier, because they didn't have to worry about all the films, because the householder sorted it for them. But of course, for the householder it was easier, because they actually could do something about those films rather than feel bad about having them. So it's a win for the householder, a win for the sorter. And then we got these bags, made them into refinable oils. Those oils went into a refinery. The refinery then made resin and various other bits. The resins went to a sheet factory, a film factory, and then we went all the way to make Kit Kat wrappers. So we've now got Kit Kats, and we have one of the leader of the project sitting, I think, in the back. We have Kit Kat wrappers, so plastic grade, food grade plastic wrapping out of this waste material. So I think that is a nice way to showcase, that we can have our cake and eat it too, or in this case, our Kit Kat and eat it too. And this technology now has been rolled out. Dow has just formally come on board, so it's been rolled out in 80 countries around the world to take care of that problem.
Fantastic insights. And you see, I'm taking notes, because as the newest research network at New South Wales Circular, we're very interested in what those barriers are and problems to be solved. Dom, have we got time for questions?
Absolutely.
Yeah, good. Okay, so I'm going to read it from here. I think, can I put your microphone? So we have an anonymous question. Decades ago, milk and cream were packaged in glass bottles, which were collected, washed and reused tens to hundreds of times. We've gone a long way backwards. How can the economics make recycling really work again? Who wants to volunteer for that one?
I can, well, you're probably much more versed than me, but the data I've seen suggested maybe you get at the best 5 reuses of glass. Again, the LCAs, the life cycle analyses that I've been aware of that have compared glass to HDPE bottles have hugely come down on the side of HDPE bottles in terms of carbon footprint. You know, HDPE melts at 180 degrees, glass at 1500 degrees. The amount of energy you have to put into recycle glass, as I say, washing isn't something that we have the infrastructure for here, and at best, before the breakage and chipping of the glass occurs, you might get 5 cycles out of it. And that comparison to HDPE is still very unfavourable in terms of carbon impact.
It's also a weight issue. I love glass, by the way. I'm a fan of glass, but for certain aspects of the packaged materials for wine is great, of course, but for a milk bottle that you return...
Even for whiskey.
Even better for whiskey. 1 liter glass bottle will weigh about 220 grams, just to give a bit of a comparison here. We're talking here, I talk about the lightweight milk bottle, 38 grams for 2 liters. So that's, let's say, about 10 times glass versus plastics in terms of weight, which you need to carry, you need to transport. So LCA, as Graham said, doesn't make sense for, let's say, high products that you have to turn over regularly. So I think plastic is the best solution there.
Pretty big considerations on carbon. Should we jump to the next one? Did you want to jump in there, Thomas?
Yeah, so in terms of the economics, because that was part of the question, so we are able, with our process, to stabilize the products with hydrogen from the water that we use in the processing, and that reduces the cost dramatically. And our internal rate of return has been verified now by companies like Dow. It's 33%. So the economics stack up very, very nicely.
Great, thank you. Has the problem been solved by the CRCP, or is the separation of the glue from the bottles still an issue?
Yes, that's me again. Like as I said earlier, we've made progress. We've improved the situation, and the less adhesive contamination and the lower temperature we can process the HDPE at are all moving towards a better outcome. I can't say we've solved it. We haven't got 0 residue. Again, the important thing is that we've got a means by which we can measure now any innovations, any improvements. So yeah, we haven't solved it, we're solving it, I guess is the thing to say.
Anybody want to add that before we go to the next? Okay, so for Jess, why not push a public education campaign to ask consumers to remove the labels before recycling? Would this have any impact?
Sorry?
Yeah, so if I just jump, sorry. So that would be, from my point of view, working very well with that project I just mentioned. Because if there was an easy way to peel the label off, you still have this trouble of the label, but we can do the thin films, the plastic wrapper and chips packets. So that can go into our bag, and the much improved milk bottle can go into the normal recycling. So all these technologies actually work with and for each other if one thinks about it systematically and holistically.
Right. Jess?
Yeah, I think it's a good question, and I also think it comes down to what ultimately is the label solution, because one of the developments that we're working on is actually where the label material itself is actually made from the milk bottle. So the label is made from 100% Australian milk bottles. So that's a development that's going on, and in that case, you actually want the label to go with the container in the recycling process, because if you separate it, you create a secondary waste stream. So I guess the penultimate solution really is that the bottle and the label can be recycled together.
And how do you extract that value?
In a closed loop solution. So, but certainly if the materials are not the same, then yeah, that is a valid point, and that's something that need to be coordinated. I don't think milk's subject to container deposit legislation. No. no. So that's not a barrier. That's a problem, obviously, in other categories where you can't remove the label before it goes into the recycling stream, because then you can't recover the 10 cents.
Yep.
It needs to have a label and a barcode. So that sort of is counterintuitive. But if milk's not subject to that, then certainly that is an option. So it's a good point.
Did you want to add to that? You right? Okay, so next one, maybe I missed it, but what is the tolerance for HDPE bottle manufacturers for contamination, i.e. what is the maximum % glue they can actually tolerate? Graham, I think that's...
Yeah, look, I haven't got a magic number
maybe
there.
we take that on notice.
Probably there will be a mix of virgin and recycled material. Where that exactly sits, I couldn't give you an absolute
Yeah,
percent.
the glue gets holes in when you blow the bottles. You have a lot of rejects you get out of it, so it's not really an option outside.
There's a question for you. How is Europe handling this issue?
As Europe handling this issue, I think that if you look at the milk bottles, there is a couple of countries that use the milk bottles, which is UK, USA, South Africa, and Australia. That are the main countries that use milk bottles. The rest is cartons and other solutions. As I mentioned, UK is doing about 30% of recycled. No, they're doing about 40%. Legislation is 30, as you saw in the presentation. Why is it 40? And they're doing this program already for the last 10 years, by the way, just for information. So they have started the program, and it also started as an industry initiative. So the milk industry, the dairy industry in UK came together and said, how can we solve this? They came with a solution. I think that we're doing the same here. We're trying to do the same here, also with help from APCO, to create something for the industry. How can we drive this? There's 30%, there's a tax on it if you don't deliver the 30. But in the end, it's about availability. So why are they at 40? Because there's not more available in UK. It's about getting the recycle to work properly. So I think, how is Europe doing that? So they're also on the way. They're on the good way. They're not there yet because they're at 40% at the moment. Yeah.
Right.
So,
okay.
yeah.
Thanks, Ad. We've got one for you again, Graham. I'd be interested to know how hard or how costly it will be for recyclers to adapt their processes to implement impact delamination and the new washing process.
That's the big handball. Yes, I am from Melbourne. So yeah, that's really one for Brian and his team to answer. I guess we haven't been the developers or the conceivers of the impact delamination process. So I don't know, Brian, whether you'd like to make comment there. I think we're still at a fairly nascent stage in the development.
Well, the washing process is a trivial exercise, and it can be used in a way that's very similar to processes that are used in industry already. Using the impact delamination process for this, it's a matter of scaling it up, and we're doing mathematical modelling at the moment to see what we would need to do to scale it up and be able to do it, as I say, on a big scale. But in the process of doing this, we have come across all sorts of other innovative things you can do with impact delamination, and I think you'll be seeing those in the not too far distant future. But yes, so the scaling up of impact delamination is something we have to do, and when we do it, we'll be doing it for a whole lot of different things, not just for recycling milk bottles.
Thank you. Do we want to take some questions from this audience here? We've had some online. We've got someone in the 2 rows behind you, Dom, or after you if you're going first.
Hi, Nick Campbell from Wellman Packaging. I just had a question regarding, this has been mainly focused on label adhesive contamination. How can these developments, particularly the wash tank reiterative process, be applied to other contaminants? And in terms of the long-term play with recycled materials, the recycling process, at the moment there's a lot of mechanical recycling with vacuum technology that draws off volatiles. and there's refresh technology that's coming onto the market. But there's also earlier mention of pyrolysis for thin films. Surely for the higher contaminated materials, pyrolysis is probably going to be the long-term solution once it becomes more commercially viable. How does this fit in with that long-term play for materials? Can adhesives be made to be removable under existing recycling technology without the extensive washing? And what other contaminants can we look at with the systems that have been developed, that have been presented today?
Who wants to take that one? We need a volunteer.
I guess.
Oh, okay.
This man.
There's a few things in there, so
Give him the curveball.
Catherine.
or the project is that we have a tool, basically, to test other types of contaminants. We have a team, Sydney, who can identify whatever else is being targeted. Because the only way to manage something is you've got to measure it first. And you need to do that in a way that is practical. And as Thomas is saying, you know, there's a lot involved in this sort of thing. So trying to have a tool that can make that easier. So I can't answer it specifically, but when we designed the project originally, we thought of, you know, target on one individual area to get the basics locked down, but make sure it was broad enough and flexible enough so you could then look at many other variations after that.
Okay, I've just got a question here for Kathy Fagg and Alex Siebel. It says, how can industry and researchers and government respond further to the towards a waste-free future report? Can we get a microphone? Are they here with us? Yes, there we are. Thank you, Kathy.
Hi, Catherine Fagg, and I'm a fellow with the Academy of Technology and Engineering and a co-chair as well with Drew Clark, for those of you who know Drew, where we've been doing a project over the last 3 years, or a couple of years, under the very strong stewardship of Alex across here, and looking at that whole question of how does Australia ensure that our industries are ready for the technology that is both emerging and is already present by 2030. And we've looked at 3 industries. We've looked at transport, health, and most recently we looked at circular economy, which is of course the discussion today. And we looked at what were the key factors in terms of ensuring that Australia is actually prepared and a very effective user of technology. And I suspect it won't surprise many people in this audience that the key lessons that came out from all the research that's been done is that in most cases the technology is actually largely available. There is actually a fairly high level of social acceptance of the use of technology, and it was actually more in ensuring that we had the right policy and regulatory settings that, as well as making sure that the economics would work, that is really going to drive change and ensure that there is uptake of technology, but that Australia is a very effective user of technology and creating new industries where that's appropriate. And I was reflecting this afternoon in terms of what do we need to make a difference? And I actually think this session is a really good example of what we need. So first of all, you clearly need a government that is very engaged. And so when Gabrielle was talking earlier and talking about the emphasis in terms of engaging and stepping in and saying sometimes we absolutely need those signals, as well as to have economic support to bring about change, is particularly important. The second aspect is then making sure the industry itself is prepared and is actually pulling through with the demand for change, and then finally making sure that we've got our research organisations aligned to deliver results and working collaboratively. And we've already touched on earlier this afternoon on the challenge of getting collaboration happening, which we know is not particularly good in Australia. So if I went through the checklist from this afternoon, I would say it seems to me that we've got a very good case study of the things that need to happen to bring about change. The only challenge for us is we need it to be happening across so much of the economy, and in some areas that's quite challenging. Alex, can I just hand over to you and see if there's anything you'd like to touch on? Because you've also seen the work in depth. As I said, we started with transport, but then went to health. And health is a wonderful example of how there's been some leapfrogging as a result of COVID-19. But anything else that you'd like to cover?
Catherine, that was an incredible summary, actually. I just wanted to touch and support, I guess, a couple of points that Thomas made earlier, which came out strongly in our research. And I'd like to acknowledge also Damien Jurko, who's in the audience, whose point I'm about to make, which is that one of the helpful things government could do is to set a target. And the target that we recommended in the report is double resource productivity by 2030. So that does all of the things that Catherine has just mentioned, which are to set policy certainty, to create economic demand, and to pull through with industry in terms of creating those markets. The other thing that we have recommended strongly in the report, and if anyone's interested in the recommendations, there's a lot of copies of the summary report lying around outside, and I've got a few of the full report with me, is that government needs to set standards and certifications. And again, Thomas mentioned that recycled material needs to be, where it's at the standard, classified as a virgin material to enable it to be used in things like food grade products. So I think, as Catherine said, a number of the points that have been made today here are the key barriers that we would see from ATSE's point of view as those that, if removed, would enable Australia to be a leading circular economy.
Thank you so much, Alex. That was great insight. And I guess it's time to wrap up. I might hand back to Suzanne and if you join me in thanking our fantastic panellists here.
And thank you, Lisa, for getting such a rich discussion from the panel and getting through all the questions. So I was going to say a few words, but I've reduced them to even fewer words. So what you've seen this afternoon, as has just been said, is a wonderful example of what everybody's been talking about for many years, but is finally beginning to crystallise into the right collaborations at the right time with the right targets to achieve progress. In this case, progress in the problem of obtaining pure material from one of the major plastic waste streams that we generate through our milk bottles. But this can be extrapolated into many, many other areas. So, we can tackle paper, and this team that was assembled has big ideas about now combining sensing, chemistry, engineering, computer science into tackling some of these other problems where we're simply not able to recover sufficiently pure material from the waste streams we generate to enable those pure materials to go back into product manufacture instead of going into waste streams, or, as someone said, into lesser value materials. Remember, Hdpe bottles start with oil, and oil is a finite resource. And in fact, one of the questions we can talk about during the discussion is, do we make the Hdpe in Australia or not? No, I don't know the answer to that. I should, but where do we get the raw material from? If we get it from overseas, then we can keep it here and keep on recycling it. So maybe it's a good thing that we import it. But I don't know. It's even using something like oil as the source of our raw material is probably something we do need to tackle. So the CRCP will finish in June. There are inventions, and we're looking to take the benchtop systems that we've put together to commercial scale. The group or similar grouping looks to take on similar projects that fuse all of the technologies I've talked about, including sensing, into other waste streams. So I will stop there and thank everybody who's participated today, been so generous with their time, and we'll take it outside for for a bit of a R&R and further discussion. So, and thank you also to the Smart Sensing Network team. Don McCallum, who put this together, has been leading the CRC project. Nick Haskins, Charles Ad, who's been tagging photographs, and everybody else who's been involved in staging this afternoon. And once again, thank you to all the speakers.